Hello, my name is Janal Javier, and in this video we'll be going over Exam 3 from Engineering 232, Circuit Analysis 2, Spring 2020. Everything you see in this video adheres to the university's Code of Student Conduct while completing take-home exams. For this exam, we were tasked with designing a fourth order Butterworth bandpass filter, and for my specific exam, I was tasked with creating this filter to have the bands at 6600 and 33,600 hertz. Okay, here you can see the schematic, the schematic having 5 total op amps, each op amp having its own utility. Op amps 1 through 4 are used for filtering, while op amp number 5 is used for scaling. Op amps numbers 1 and 2 on the right side, right before U5, you can see is used for low pass filtering, which is designed for the upper band of the filter, while op amps number 3 and 4 on the left side are used for high pass filtering, which is designed for the lower band of the filter. Here on the next page, we can see the calculations. You can read up more on how I calculated it with the submission link files, which you can go back there to check. But long story short, the fourth order bandpass filter is designed with 2 fourth order filters, one low and one high pass, which is a prototype created from 2 second order bandpass filters cascaded into each other. Here we can see the MATLAB script that was used to calculate the capacitor values, which we had done using the frequency scaling and the magnitude scaling, as well as the original capacitors that were calculated in the previous page, as you can see in my submission link. And right here we can see the MATLAB script used to calculate the resistor and capacitor values used for the high pass filter. Again, this time we used the frequency scaling, magnitude scaling, and original resistors to solve each of the values. Again, you can see more information on the calculations in the original file from my submission link. Next, we can see the completed schematic. Again, on the right side, you can see the low pass filter used to create the upper bound, and the high pass filter on the left side used to create the lower bound. The only difference in this schematic compared to the original is that U5, we have the output of the filtering connected into the non-inverting input of U5 op amp. This is because we were tasked in the exam to create the gain to have a positive 100. If we were to put it on the negative input of the op amp, it would become negative 100. The values of the resistors are a little bit obscure, but this was because we tuned the circuit in order to have as close to 100 times voltage gain as possible. And as you can see in the analysis graphs right here, the VO2 over VI shows us the low pass filter. The VO3 over VO2 gives us the high pass filter. And the VO3 over VI gives us the total filtering. Here we can see the graphs further, just by themselves. VI, the input, has no change. The VO2 gives us the low pass. The VO3 by itself, which is the same thing as VO3 over VI, gives us the bandpass. And the VO4, which is the same thing as VO4 over VI, gives us the gain. And here in our last figure, we can see that the VO4 has 100 times voltage gain compared to the VO3. Despite, other than that, there are almost no differences, as we can see that the Bode plot shows us that it passes anything between 6600 to 33,600, where the Bode plot cuts off at those frequencies. Again, for more information, just check out the attached files in my submission link. Thank you, and have a good day.